Introducing the Fairchild T9000 family of I2P transducers with full PID tuning capability and digital display. Additional features of 200 psi supply pressure capability and 3 pressure ranges, 0 to 30, 0 to 75, and 0 to 150 psi output, along with elastomer options of nitrile for most applications and Viton available for more demanding environments. Our modular design concept allows a single common electronic pilot transducer section to be incorporated with 6 different booster sections to meet the flow demands of every application. With this modular approach, each customer can choose the desired level of performance to meet their application needs and budget. First, we have the base T9000 model with 1/4 inch ports and 1 SCFM flow capacity for small pilot signal circuits. Next in the line is the T9010 also with the 1/4 inch ports, 12 SCFM forward flow capacity, and 4 SCFM exhaust capacity used for slightly larger applications. Our most popular model, the T9020, is shown next with 1/4 inch, 3/8, or 1/2 inch ports available with 90 SCFM forward flow and 45 SCFM exhaust flow. Next in our line we have the T9040 with 1/4 inch, 3/8, or 1/2 inch port sizes and 110 SCFM forward flow and 55 SCFM exhaust capacity. Next, the T9060 with 3/8, 1/2, or 3/4 inch port options with a very high flow capacity of 220 SCFM forward flow and 110 SCFM exhaust capacity. And last but not least, our T9080 series with 3/4 inch or 1 inch ports and a massive flow capacity of 700 SCFM forward and 300 SCFM exhaust. This model has one of the highest flow rates in the industry. So as you can see, we have performance for every application, low or high flow. One of the most important features of the T9000 series is the onboard full PID tuning capability. Unlike some competitive models, our unit can be fully tuned using only the keypad. There is no need to download a program to a PC to make changes to the parameters. Not only do we offer full PID tuning, but we also include adjustable deadband and supply pressure compensation feature, which some competitors typically do not include. These are also beneficial to achieve the highest level of performance for your system. In an electronic control device, many times a PID control system is included to improve performance and assist with adjusting the control process of a valve. PID is a control loop feedback system where a controller calculates an error based on the difference between individual process variables and a desired set point. The controller calculation involves 3 different terms: the P or proportional, which represents in terms of time, present error; I or integral, which is a sum of past error; and D or derivative, which is an estimate of future error. The 3 individual variables are summed and fed back to the processor to adjust the control process. To explain PID tuning and how it works, we will look at a few graphs showing output pressure performance for various changes in the tuning parameters. First, you see in Figure 1, performance with the proportional term, or Kp, equal to 1, and all others set to 0. Here the output, shown in red by the red line, approaches a set point, or 50 psi, shown by the blue line, but does not go all the way to the set point due to the error present in the PID feedback loop. Next, in Figure 2, as Kp is increased to 5, the error is reduced. However, the output pressure overshoots the set point as seen by the line shown in black. Now in figure 3, as we add in the variable Ki of 0.02, the overshoot is larger than before. However, the error over time, as you can see, goes to 0, as seen again by the black line. To further improve performance, we can introduce to the system another parameter, Kd, of 0.01, which is seen in figure 4, and the black line again reduces the overshoot of the set point, but at a slightly slower response time. Last, in figure 5, you can see a composite of the 4 graphs for comparison to show how we were able to tune the output response for optimum performance. In making tuning adjustments, there are always trade-offs, so it is important to know whether response time at the expense of high overshoot or reduced overshoot for better accuracy at set point is most important, and make changes to the parameters to achieve the desired result. The benefits of PID tuning are obvious. The improvements that can be achieved in system response time can save a few seconds for each manufacturing operation, which will save thousands of dollars in labor and improve overall production output. For applications involving applying coatings or paint, improvements in response time can cut costs by conserving materials by more rapidly controlling the application. As you can see, the T9000 series of fully tunable I2P transducers allows each customer to select the level of performance and flow capacity for their application. Thank you for your time. If you have any questions on any Fairchild products, please give us a call.